All right, so now we're going to have a look at a different way of expressing a complex number. And I believe I talked to you about this. Sometimes looking at it in a different way really helps some things. And this one is one of those cases where looking at this in a different way actually makes some things more obvious and also makes some things much easier. Makes other things more complicated, but as long as you know what each thing's good for, really powerful. So we've got here some real number, and we can say that its coordinates in this argand plane is the real amount of z, and then its imaginary part. So that's like our x and y, if you like. Now, the polar form changes the way we express this. We talk about here the distance from the origin, which we're going to call r for radius, and then we talk about the angle that it makes with this x-axis. So when we have a polar form, then we have an r value and a theta value. So if I've got an r value and a theta value, how do I convert between them? So I'm going to start with going from polar to argand because it will teach us something useful, but then we'll look at going the other way as well. So if we think about this as a triangle here, I've got a right angle triangle, I've got my real part along here, which is my x, and I've got my imaginary part here, which is my y. That's a right angle triangle with an angle in it. So we can, and the r is my hypotenuse, so I can use my sine, cos, and tan. So I can go, well, I want to know something about my real in respect to these two, my knowns, my angle and my radius. Well, that's my adjacent and my hypotenuse. I want cos theta equals my real of z over my r, or I can rearrange this to say my real of z is equal to r times the cosine of this angle. Now, looking at this bit, my imaginary part, want to know something about that? Well, that's going to be my opposite and my hypotenuse. So I've got sine theta is my imaginary part of my z over my r, or rearranging that, I can say it's my imaginary part of z is equal to r sine theta. And so we can write these, and we do write it in polar form in this sort of way, even though this is sort of a argand or Cartesian sort of way of writing it. We write z equals r cos theta plus, and now we've got an I in here, so we usually write the I first, but that's just so that it doesn't get mixed up. Now we could pull out that r, and we can write that in a short form. So we go r, and then we abbreviate cos plus sine I sine to cis. So cis stands for cos plus I sine. And that's how we write it in polar form. Okay? And that directly translates to working out what our argand form is, because if you just calculate what the sine and the cos is, you can plug them back into your thing. Now, going back the other way, if I've got my real and imaginary, how do I get my r and my theta? Well, the r is part of a right angle triangle. We can use Pythagoras. So we can say the real part squared plus the imaginary part squared is going to equal my r, but I want to do the square root. Now that's exactly the same calculation we did for magnitude, and effectively it is the magnitude of a vector. Now getting the angle is a little more tricky. So my angle, if I look here, I'm using these two. I've got opposite and adjacent, so I can say tan of my angle equals opposite, so imaginary part of z over the real part of z, and then I can do my inverse tan. Now you do have to be a little bit careful. There's multiple ones. It helps to draw a little diagram. Imaginary over real. I'll give you an example in the next video.